You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. So I've had a few opportunities to talk to Adam over the past few months, which has just been great. I'm here with Adam Jacob. He's the founder of System Initiative. Probably, technically you're probably co-founder, or are you just founder?
Yeah, I'm a co-founder and CEO. I prefer CEO comes first because like a founder is a thing you do for like a second.
Yeah.
You're like there and you're like, oh, I did it, But like more interesting is that I continue to be good at the job. I think.
Yeah, apparently.
Willing,
Yeah. I mean, that's always a plus,
Yeah.
Especially when you have other people invested in you,
Yeah.
So like both personally and whatever else wise, financially,
Yeah.
So like, so we were talking at reInvent and we talked about user experience and we talked about, all kinds of stuff. I mean, we talked about, no matter what you think about Tesla or not, like apparently, Adam, it has a fart noise. I made a little video about it, which I just share with you. But what it comes down to is like we were talking about Descript and the user experience there and how great it is. And that's kind of a big part of System Initiative and the DevOps platform you're developing. So I want to get a little bit into that user experience. And then we can move on to other topics like the narrative that we see unfolding, because what I see is a narrative unfolding with efficiencies. When efficiencies get better, the narrative gets more interesting. So perhaps we can dig a little bit into that. But first, why don't you just tell us about the company and that kind of focus on the user experience?
Yeah. So System Initiative is the future of how you're going to do enterprise automation, DevOps automation, whatever you want to call it, sort of more broadly. And basically the way that it works is rather than thinking about how you write all this code that describes how to then run your infrastructure or automate your enterprise, instead what we've done is build a model of how to assemble the automation itself. So a good way to think about it is, if you run Formula One race cars, right? They can go to the track, but they only get 2 days at the track before they have to race. And so if you show up with your car at the track and then try to tune the car to the specific conditions, like you're just going to lose. So instead what they do is they build these really high fidelity models of the car, right? They build a model of the tires and how that works. And they build a model of temperature and they build models of the track and they build a model of the engine and all this stuff. And then they use a simulator to run that car, often with an actual driver in the simulator, but often without them, to like tell them what the right baseline is for this car long before they ever get there, right? And you see a similar kind of idea. What those people are doing is building a model, right? They're building not a model in the sense of like model view controller, but instead in the sense of like, how can I see this system digitally, interact with it, and then understand how to use it to get the outcome I want to see in the world. Another example of this would be like video game developers using Unity, right? Unity is a model of how video games get constructed, right? If you go look at what Unity can do for you, it talks about like, all the different things you need to do to build video games from all the different points of view, right? It's how am I building shaders and how am I doing, how am I going to think about adding scenes and how am I going to have character models and how am I going to, do matchmaking and all the stuff that's required for a modern video game sort of lives inside Unity's model of what a video game is. And so the big idea behind System Initiative is that we've built that model for enterprise automation. And then because we have this incredible model, we can then start to allow you to then extend that model in interesting ways, program it, and it makes all the really complicated things you have to do in order to make things work much, much simpler, right? So we can are much easier to do. So the problem is still complicated, but like the interactions are better. So a good example is, when you're working with your team, you can work in System Initiative in multiplayer to see what the architecture would be in real time. And it'll tell you in advance, like this would work or it wouldn't. It knows how to assemble the components. It knows what their relationships are. And it can give you this very fast multiplayer feedback loop, which is super great for putting together infrastructure, for explaining it to other people, for showing engineers how to use it. And then when it comes time to extend the system, you actually can just write code that is basically these tiny reactive JavaScript functions that then actually do the automation itself. So, if you wanted to do, things like, look at an existing architecture and migrate it to something else, you can actually just write a function that takes in the existing architecture as an input, then transforms the information and writes the new architecture as an output. And then you would see all of that visually in this magical diagram. It's very, very cool.
So let's rewind a little bit, and how has the community allowed you to get to this point, and in a way that allows for the efficiencies that you provide,
Yeah,
to be able to allow people to build out their own services with these really easy to use tools?
Yeah. I mean, there's sort of two pieces, right? One is that I've been around a long time. So, I started doing this kind of automation 1997, 96. Mark Burgess published the first paper for CF Engine, which is sort of the birth of this idea of infrastructure as code and sort of what we think about as modern automation, 1993, right? So like I've sort of been around and seen it evolve over a long period of time, and I've had some success in helping people understand how to reason about these systems and how to use them inside these really large enterprises. So part of how people have allowed me to do this is that I'm them. You know what I mean? That's the work that I love. It's the people that I love. It's the place that I've invested my life and my career. And so when I say that I've been thinking a lot about the problem, I'm not, like sometimes it's marketing fluff, where it's like, we came from outside and we invented a new way to solve this problem because the people who actually know this problem were, obviously too dumb to solve it. That's not what I'm saying at all. Right? I'm saying, oh no, I'm you. Like I so understand what this is. And because we've had some success, we were able to sort of step back and try to imagine what's in our way of moving forward. And so, part of it has been that credibility of like, yep, we know what these systems are. We're good at building them. We know what to do. But that credibility only gets you into the conversation. Ultimately, it has to be the experience that people have and the problems that they solve using the technology we produce and the product we build. And so that process of doing it has been delightful, because what you tend to see is, people show up, they use the product, it clicks pretty quick, they understand why it's better. And then we start having conversations about like, what's in your way? Like, what do you need to see? What does it need to do that's bigger than it does now? Or what's that missing feature that sort of, when you think about how you automate your infrastructure today, you need in order to see system initiative and get those benefits. And so we're in this very fun minute of the company's life where we're having those conversations all the time and then really rapidly turning out solutions that are really, really great. So for example, one of the things you really want to be able to do is we built this big dynamic graph of all these functions. And you really want to be able to use your regular editor when you edit them. It'd be great if you could. But they're inside this very complex model, right? And so what we've done is built like a fuse file system that allows you to just mount the model in a file system and edit it directly. It's sick, right? But like that happened from customer feedback. It happened from this conversation about like, oh, here's what I need to see. And then coming up with ways that this new primitive we've built like allows people to experience, allows us to build experiences for users that otherwise would be really, really hard.
When you think about all of this community, when you think of this community that you've been a part of for all these years, right? And you talk about, 1997 as a marker in your life, and now we're at, 2025.
Yeah.
That's a long time.
You can see the gray in my beard.
Yeah. I don't have any gray in my beard, but I barely have any gray on the top of my head,
Yeah.
But in any case,
we're old enough.
We're old enough. But I'm curious about still the narrative unfolding then, with what you're developing. Because the narrative doesn't stop. It continues and it changes every time.
Yeah. I think about it as there's a professor, I think he was, his name is Peter Nauer, and he wrote this paper in the 70s or 80s, early 80s maybe, that basically talks about programming as theory building, and says that the job of software development is not writing code. It's actually the internal theory of how the program works and how it interacts with the outside world to solve problems. And the better that theory is understood by the developers who are working on the problem, the better their ability to then create high quality solutions to those problems. They can adapt the program to conditions. They can do whatever they need to do. And I think that ongoing narrative is really about this constant conversation of sharing what that theory is. Here's what system initiative is. Here's what it can do. We've been having a conversation about what sort of infrastructure as code can do since roughly 1997, depending on who you are, right? 1993, if you're Mark Burgess, right? Most of us showed up late to that conversation to one degree or another.
Right.
But we've been having this very meaningful conversation about what is possible based on that theory and adapting it over time to new technology and all kinds of things. And I think what's so fun about System Initiative is that right now we're at this beginning part of a new theory where it's like, what if there was a completely different foundational way to solve this problem? And here's all the new ways you can imagine solving problems that would have been intractable before that are now possible. And so when you think about how it evolves over time, it's really just getting into that conversation with more people. It's finding those experts. It's finding those and rolling around with the problem and being like, oh, but now we have this new capability that has this different shape that can actually build a model of the things that we already have and it lets you do live interaction with that model in a multiplayer way. What's that mean for migration of cloud workloads?
Okay.
Right?
Okay. Yeah. So I wanted to look at it from two contexts. One, the multiplayer dimension.
Yeah.
And secondly, the digital twin dimension. Perhaps you could talk about that talk about this change in theory, this change in the narrative from those perspectives.
So think about it this way. Like what we know brings about good outcomes in DevOps in general is the amount of collaboration that happens between all the different people who need to be involved in the process. So application developers, infrastructure engineers, security people, network people, the closer those people can come together and the more they can collaborate on the problem and the more they can share with each other the theory of why their application works and how it runs and what they need, the more effective we are at delivering solutions to people in the outside world, right? Like actually solving their problems, right? But the existing way we work was not designed with collaboration in mind. We discovered that collaboration was critical, right? Because we didn't design for it. We didn't say, what's going to make this work? System administrators talking to application developers all the time. Like we learned that was true because we weren't talking to each other, and the people who did talk to each other got better outcomes. But we didn't then take that truth and redesign the technology around it.
Right.
You know what I mean? We just were like, oh, great, you should talk to each other more, This is why you wind up having DevOps talks that are like, it's about culture and not tools, because the tools do all for you, right? In terms of actually moving that piece of the puzzle forward. Sorry for swearing. But the, when you get into so this idea of it being multiplayer, part of what happens is you want to say, hey, if collaborating together is the thing that we need, then we have to be able to do it together in real time, right? If I need a security engineer to look at my idea and tell me if it's going to work or if it's going to violate the corporate security concerns, I got to be able to summon that person and then quickly convey to them what it is that's going on. And right now, the only way to do that is what? Code review? Making a diagram? Summon him to a meeting? But with System Initiative, they log into the workspace, they click on my face, it takes them directly to the change set I'm in, and I can just walk them through the design. I can say, hey, here's the change we would make from how the world is today, from the environment that we're in to the environment I want it to be in. They can codify those rules, right? They could encode them into System Initiative so I could see in advance, what was right or what was wrong. And that collaborative flow really unlocks, right? Because that ability to have different people with different expertise sharing the same model of how the world works and being able to then visualize and communicate that model to each other, It's priceless, right?
Right.
So that's the multiplayer piece of it.
Right.
The digital twin piece of it is that you have to make that model a reflection of the truth of the world.
Yeah.
So, think of it this way. When we build code today to automate these systems, what we're doing is writing usually a declaration that says, give me this thing that I want. And then the program runs and it looks at how the world is, and then it figures out how to change the world to match what you said you wanted. The bummer there is that I have to understand both things. I have to know, this is how the world works. These are the operations I can make. And here's how I would specify it in this declaration to get the world to match. And then how do I reason about and show those things to each other? So what we do with the idea of digital twins says, wait a second, if you're a network engineer, you understand the world in terms of switches and routers, right? And ports, and you sort of think about the world in this shape. So what we need to do is build a one-to-one model of that shape for you, and then let us interact with that shape. What are the relationships between those things, right? What are the properties of a switch? What are the properties of an EC2 instance? What are the properties of whatever? And then how does it relate, right? Maybe I have compute that has network ports that are attached to switches, right? You can start to think about how that model emerges. And so how System Initiative functions.
So just to back up.
Yeah.
The model has to be a reflection of the world. You might know the physical world of switches and an instance.
Yes.
But the relationship has certain dynamics in it that requires a certain degree of help in keeping that relationship structured to some extent.
Yeah. Yes. You need when you think about it as a modeling problem, right? It becomes a problem of just saying, what are the properties of this thing that I want to manage? What are the activities that I do with it? Right. So, a switch, I can plug things in, right? I plug it in, I take it out. I have layer 2 VLAN stuff I can do, maybe whatever it is. You model those actions and you model its properties, and then you model its relationships. And that tends to actually be enough in digital systems to give you a pretty great working model of how the system actually behaves. As long as it's very granular and very high fidelity, where it doesn't, right? So part of the trick we've done here is that we build those models very granularly and in very high fidelity, which then allows them, as you scale up semantically, to do the right thing.
Okay, so that allows for that semantic. That allows for the semantic discussion, collaboration to emerge.
Yeah, I don't care. I maybe don't care what switch it's plugged into unless I do, right? And so, if I'm an application developer, I mostly want to deal with the semantics of deploy my application. Now, to do that, it might need to interact with a switch, right? So by having all of that modeled in the same system, it allows a developer to say, I want to deploy the app. And then the actions required to transform from the undeployed application to the deployed application happen first in this simulation. They happen first on models, and then they take action on the outside world to actually change how the world works. And you can see that flow in a way that you can't right now, right?
So that's a change in the narrative. What are the challenges of that narrative for you as a technologist?
Oh, I mean, the biggest one was just figuring it out. It's taken many, many, many years of R&D to be like, is this better? Are we on the right path? Is there, because it can't just be good. There's a version of this that is very easy to build. That's a toy, right? But I don't want to build toys, right? I want to build things that will power the most complex problems on Earth. I want to solve the most complicated technology problems on the planet. That's what I want to build technology for. So, it's difficult to both conceptualize what that primitive would be like, and then to pull it through into the world and be like, no, this is powerful enough that we can use it to really like solve gnarly problems.
I'd like to challenge you on that then.
Yeah, please.
Because if you're trying to solve all the technology problems, isn't the problem more of a cultural problem? Because that's what you were saying earlier. It's more of a cultural problem than a technology problem.
Well, here's what we learned from DevOps. Culture is the ossification of your technology in process. So you can decide all day that what you want to be as a person who knows who continuously deploys. And it doesn't matter if the system won't allow you to deploy continuously. Yeah. You can be converted, you can find faith in whatever the thing is I convince you of, but you can't you can't actually know that it's going to work until you actually build a working system and work it. And so when we talk about it being a culture problem, the way you change people's culture is, yes, there's a bit of evangelism where you're like, hey, you should understand this and you should like do this. But ultimately, it's not. Ultimately, it's if I change the way you work, I will change your culture. If the way that you work is you file tickets and people expect to come into work in the morning and read a ticket and then do the work, and then they go home when the clock runs out and they work as many tickets as they work, then that's how you're going to build your technology culture, right? You're going to build a culture that works as queues between bespoke teams where you're going to have to flesh out the tickets more so that you can make sure that every person who receives the ticket has everything to do the work. And of course, you'll be slow. You can talk about that as a culture problem, but it's ultimately not a culture problem. It's actually a technology problem. It is ridiculous to decide to do that work that way with that technology. And when you do, it creates a culture that you hate. So those two things are co-committant, right? Culture and technology drive each other. So to change the culture, you change the technology.
Yes, they do. The question then becomes one about, in some respects, is one dimension of the problem comes when you think about constraints. And what we find with constraints over and over again is how valuable they are. Mm-hmm. And I'm coming on to this conversation about narratives and efficiencies because, as we all know, the news we have right now, kind of at the top of the heap, is DeepSeek, right? Mm-hmm. And DeepSeek's an interesting story, and there's been a few kind of dimensions. One, it's captured everyone's kind of imagination very quickly, in all the headlines. Yeah. Number two, it speaks to the cost dimension that comes with developing AI, as we've been told it requires, right? But number three, it speaks to what you can do when you face constraints.
Yeah.
And that constraints and leads to efficiencies that you never imagined could be possible. I'm curious on your thoughts on constraints with system initiative and your own work.
Yeah. There's a famous phrase, art needs limits.
Mm-hmm. It does.
And it's just true. It just does.
Yeah.
And so while my aspiration is to create a technology that can run the most complex of enterprises, you don't start there.
Right.
Right? If you start there, you'll never finish. So you start from smaller things, and then you start to see how those things can impact the broader world, and you sort of build up your way there through this unlocking of constraints, right? Through breaking through those barriers, you sort of discover what's possible next in the art, So if you think about music, you can chart a course in music where, there's moments in time where artists break through a barrier of the genre or of the style. And then suddenly that's the style forever, right?
Right on.
Nirvana, right?
Right.
Before that it was Poison, and
right.
Boy, Poison sounded awful for a minute the moment you heard Nirvana, right? Even though Poison is incredible. What a great band is Poison. But in that moment, it was deeply uncool to like Poison. And it happened instantaneously. So I think those constraints, we think about something like DeepSeek, it comes back to this idea that often, because our understanding of the theory of how these things work as technology isn't evenly distributed, and something like AI, it's presented in marketing as this mysterious thing that you couldn't possibly understand. You gotta have a math PhD, and the robot, how could it possibly do what it's doing? And that's part of the mystique that causes it to have its valuation go higher, which then, you know what I mean? It's part of the machine that gets everybody hyped about it. what you see with stuff like DeepSeek is that, okay, what's the real thing that causes this efficiency to happen? Not on just training, but on inference. And the answer is they built a router. And if you think about it as a technology problem and you say, I have a giant distributed system that has 900 billion object items in it. And every time I want to do anything, I have to send a broadcast message to all 900 billion of those things. That's roughly what's happening when you ask a giant AI model what to do. We light up every neuron and we see how it feels about things. And instead, they were like, well, let's break it into smaller pieces and build a router. So we know that there's a cluster of neurons that are related to the kind of task you want to do. And I'm going to do that. And suddenly, the whole thing is dramatically more efficient. And when you explain it that way, you're like, of course, obviously, right? All it took was understanding what's the technology in front of us. What do we know about similar size and scale, right? It'd be the equivalent of like, hey, to talk on the internet, you have to just blat a packet to the whole internet and be like, do you want it? It's ridiculous. And so there's like other invention that lives inside of DeepSeek, but you can see how for them, like that constraint coupled with their knowledge of the theory of how those systems are constructed and a little ingenuity about that inefficiency unlocks what feels like magic to everybody else.
Yeah.
And, I think our game as technologists is always to figure out, how do I look beyond whatever the hype is that someone's saying, or beyond whatever it is, not just about AI, but about system initiative or whatever it is, and be like, okay, but show me the theory. Tell me, I want to know how it works, because once I know how it works, now I can go with you. I can think about how we can use it. I can think about where the applications are. I can think about how those things live. And I think with AI in particular right now, we're kind of doing ourselves as technologists a disservice by believing that it's sort of beyond our ken, like it's like, oh, it's sort of beyond us.
Oh, we can't do this.
And you just can't, that's bullshit. You just can't believe that, right? As soon as that, like, it is in some people's best interest that we believe that it's beyond us, but it is not actually beyond us. And the sooner we realize that, the better we'll all be at actually using this incredible technology to do actually interesting things instead of just random, arbitrary.
I mean, think if the PC tower just got bigger.
Totally. I mean, but like the PC thing's a good example, like when we got the first PC in my family, like, my mom, we bought it at Sears. My mom was a real estate agent. We bought it so she could had a modem so that she could dial into the MLS, because it was a real game changer that she could call into this bulletin board that the multiple listing service ran for house listings. Incredible, right? But I wanted to know how the computer worked. I took it open, I was like, what are these pieces? And if you take the case off, there's all this stuff inside of it. And she was like, dude, do not break the computer. This was an expensive thing we got here. Let's figure this out. But that desire to figure it out, that desire to know what it is, it's that same thing. And there's nothing about AI that's any more mysterious than how that PC worked when it sat on my desk. There just isn't. And we have to treat it that way. And, I don't know, it feels like a mass delusion that we're not,
Well, I think we should end this conversation on mass delusions because, there's a lot of mass delusion out there right now.
Yeah. And I think it's unnecessary. If we could just calm down a little bit and think about it more directly and have some conversations more clearly about what we actually want and what we don't, and, where to find common ground in getting it as technologists, we would go a lot further.
Maybe DeepSeek should be like Deep Week, because the week can only get deeper if you think about it that way, right? You can go deeper into the week. You don't have to seek out some deep thing. It takes time to do that, to seek out the deep stuff. You need a deep week. You need a deep month. You need a deep year.
Absolutely. It's okay to not be the person who is also going deep in everything all the time.
Right.
You can't always do that, but that doesn't change the fact that if you needed to go deep, what you're approaching is new technology, and you know how to do that. You know what that is. And And that's the thing that I find most frustrating.
And make it fun in the process, right?
It's always fun. It was fun
Right?
when we took computers apart. It's fun now. Like,
Right.
how fun was it?
But giving the user something fun.
Yeah, of course.
Like what was so wonderful about Slack when it first came out? Well, it had all these little funny little bells and whistles. I mean, over time it looked like kind of just like, why do we
Yeah.
need this? But when it first came out, it was like, wow, this is so kind
Yeah,
of cute. It's so
absolutely.
easy.
Every person who ever used Docker the first time,
Yeah.
the first time you typed Docker run MySQL and hit enter, and it went and downloaded MySQL and ran that thing for you,
Yeah.
you were done.
Yeah.
You
You're
know,
like, wow.
you were crawling over broken glass. It was not stable software. It did not work very well. It had
Right.
a ton you had to add to it. It was crazy town. And also, it was so fun. And it didn't matter sort of what was in your way, right?
Well, best of luck with System Initiative, Adam. I always love our conversations, and
Me
so
too.
I hope we get the chance to meet in person soon.
Oh, I mean, always. Like, it's so fun to
Yeah.
actually have these conversations together.
All right. Have a good one.
You too.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.